Recording now, this is lesson 1.4 on exploring factors. Before watching the recording, please make sure that you have the 1.4 Exploring Factors worksheet in front of you. Along with that, you should have a highlighter and a pencil. If you need to stop the recording and get those items, please do that now. Otherwise, I'm going to continue. Just make sure that anything I'm writing in black, you're writing in pencil on your page. Anything I'm using a yellow highlighter for, you should be using a highlighter on your page. And at any point during the recording, if you need to pause the recording to catch up on any notes, please do that now, or please remember to do that. So let's get started first off with the vocabulary. Vocabulary to know for this lesson, some of it is review from a previous lesson. So let's go with factors first. So factors. Factors are numbers used to form a product. For example, 3 and 5 are factors of 15. So we know that 3 times 5 will get you 15. The next vocabulary is common factors. So they are factors shared by given products. For example, 3 is a factor of 12 and a factor of 15. So 3 is a common factor of 12 and 15. So we would have done that in the previous lesson when you were asked to do the factor rainbows and find the common factors across two numbers. Related to that is the GCF, or the greatest common factor. So remember that that is the factor that is greatest among all the common factors of given products. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12, and I'm going to highlight 6 there. The factors of 18 are 1, 2, 3, 6, 9, and 18. Therefore, the GCF of 12 and 18 is 6 because that is the largest factor that's common in 12 and in 18. Next is prime number. You can't see that there. A prime number is a number whose only factors are 1 and itself. So this will come really key in this lesson. So if you think of all the prime numbers that are less than 10, for example, you actually have to start off at 2. 1 is actually not prime. It's a special number that we call a unit, but 2 is the first prime number. The next prime number after that would be 3, because 3 only has 1 and itself as factors. The next prime number after that would be 5, because again, it only has 1 and 5 as factors. The next one would be 7. Those would be your prime numbers that are less than 10 as an example. The next term that we have here is composite number. And composite number is a number with 3 or more factors. So an example of a composite number is 9 because 9 has 3 factors, 1, 3, and 9. So it's composite. So again, those are terms that you need to know and be familiar with as we move through this lesson. The goal of this lesson is to do something called prime factorization. And I'm going to jot down that term up here. Oops. Okay. So prime factorization. So what you're going to be doing is you're going to take a number and factor it down until you get only its prime factors. So remember what a prime number is. It's a number whose only factors are 1 in itself. Okay, so these are the examples that we listed here, 2, 3, 5, and 7. There are way more prime numbers beyond 7, but we've only listed those 2. So what we're going to do is we're going to write 12 in this first example as a product of prime factors using a factor tree. So what you have to understand about a factor tree is that it only deals with multiplication. Okay. So, and I'm going to write 12 here, or I actually have 12 written right here. So 12. Now think to yourself, what two numbers multiplied together will give you 12? So I know that one of the arrays of 12 would be 2, and 6. Notice I've written 2 and 6 underneath 12 using 2 lines that are connected to 12. This means 2 times 6 equals 12. Another array of 12 I can think of is 3 and 4. Now, yes, you could have 1 and 12 as well as another array, but for the purposes of this, we're not going to be using 1 in itself as factors, and you can see why in a second. So, looking at all the possibilities, what times what equals 12, we have 2 times 6, and we have 3 times 4. So I'm going to pick 2 and 6 here, and I'm going to use that as my main way to factor 12. So, now remember, the goal is you want to have the bottom of any factor tree having only prime numbers. So I look at this and I go, well, 2 is prime because it only has 1 in itself as factors, but 6 is not prime. So what I'm going to do is I'm going to break 6 down again into more factors. So think to yourself, what number multiplied by what number will equal 6? Well, I know that 2 times 3 will give me 6. Now I'm going to carry this other 2 on a single branch here because we need to make sure that our tree is balanced. Looking at the bottom of this tree now, do you see that we have all prime numbers? And do you see that when we multiply these 3 numbers, we will get the top of our tree, 12? Because 12 equals 2 times 2 times 3. And anytime you finish off a factor tree, make sure you write that down. Okay? So that's the number 12 for you. Now we'll move on to the number 72 on the other side of the page. We're going to follow the same process that we did for 12. But this time, we have a bigger number to deal with. So, again, think to yourself, and maybe pause the recording before I go over the answer, as to what 2 numbers multiplied together will give you 72. So I think to myself, okay, 72, we can do 2. We can do 2 and 36. 72. We could do, let's do 3 and 24. I'm not going to do all the possibilities here. We could also do 8 and 9. It doesn't matter what you start off with at the top of your tree because the bottom of all the trees, so long as it's factored properly, will have the same numbers on the bottom. Because remember, what you want to get is all prime numbers at the bottom of the tree. So what I'm going to do for this one is I'm going to use 8 times 9 as an example. So remember, the way you look at it is 8 times 9 will give you 72. Now, ask yourself, is this number 8 prime or composite? Well, it's composite because it has more than 1 in itself as factors. So I know I can say 2 times 4 will give me 8. Ask yourself, is 9 prime or composite? Well, it's composite as well because when you break down 9, you can get 3 times 3 as factors. Now, it looks like we're almost finished, except that we've still got prime and composite numbers on this part of the tree. So what we're going to do is we're going to carry down 2 down on its own branch because it's prime. 4 has 2, is composite because you can break it down into 2 times 2. 3 is prime, and the other 3 is prime. Now you have to ask yourself, when you get to the bottom of your tree, are all the numbers prime? And the answer is yes. So you rewrite 72 equals 2 times 2, which is 4, times 2, which is 8, times 3, which is 24, times 3, which gives you 72. So you know you've completed it when, again, the bottom of your tree is made up of all prime numbers. Now, I encourage you to pause the recording and try doing 124 on your own. And then replay the recording after you've done it yourself to check your answer. Now, I'm going to continue here. Now, 124, you probably need to do a bit of division to find its factors. I know from looking at this, 124 is even, so it has to have 2 as a factor, and 2 times 62 will give us 124. Another factor of 124 would also be, so another one would be 4 and 31. So let's go with 4 and 31 as our main example here. So we know that 4 times 31 will give you 124. So again, you go through the same process. You ask yourself, okay, is 4 prime or composite? The answer is it's composite because you can still break it down into factors. 2 times 2 will give you 4. Now, 31, interestingly, is that prime or composite? And the answer is it's composite because it only has 1 and itself as factors. So we can carry it on its single branch. Therefore, when we rewrite it as its prime factorization, 124 equals 2 times 2, which is 4, times 31, which gives you 124. Okay, now, the last example we have here is 49. So if you want to pause the recording and ask yourself what 2 numbers multiplied together will give you 49, and then do the rest of the tree, you may do that now. I'm just going to continue. Now with 49, the only possibility I can come up with easily would be 7 times 7. Now ask yourself again, is the number 7 prime or composite? Well, the answer is it's prime, so you're actually done. It's a very short tree. 49 as a product of prime factors is 7 times 7. And you're finished with that tree. So to review, what we've done is we've drawn out factor trees that show each number given as a product of prime factors. So I'm just going to highlight here. So I'll highlight here. Now, on this page, we wrote the number 72, and we listed all the prime factors of 72. I'm actually not going to do that. Let's erase that. We listed all the prime factors of 72. I'll just rewrite that here. 2 times 2 times 2 times 3 times 3. We took 124. We took 124. And we listed the prime factors of 124 via the factor tree, and we also took the number 49. Now, the key thing to remember and to review is that whenever you are doing a factor tree, it is multiplication that is the operation that you will be using. One common mistake that some people make is, say, for example, let's go back to 12. Some people will do 6 and 6, thinking that 6 plus 6 equals 12, but that's incorrect. What you want to be doing is you want to make sure that you're doing multiplication. So these 2 numbers multiplied together will give you 12. So 2 times 6 equals 12. And this is how you do prime factorization of numbers.